Hey, welcome back to Mr. PL's with Algebra. This is Unit 4, Topic 1, Lesson number 4. So now we are getting into quadratics with patterns of area. So we're going to be a little bit different than the previous 3 lessons, and we're going to start off with a warm-up which has to do with slope, which is something you've done in the past using this formula. So slope you've found is this equation, y sub 2 minus y sub 1 over x sub 2 minus x sub 1, which basically tells you how much the pattern, the linear equation, is rising over running. So because change of y is how much as it goes up, and running would be left and right, how much it's changing from left to right. All right, so 17 minus 7, so that's y sub 2, because we're going to call this the first point and this the second point. This will be the y in the second point, so that's 17 minus 7 over negative 5 minus 3, minus negative 3, sorry. 17 minus 7 gives us 10, and negative 5 minus negative 3 is negative 2. I can simplify that. 10 divided by negative 2 is negative 5. So it has this line will be going down 5 for every right one. Same thing here. Negative 3 minus negative 37 over 4 minus 12. Negative 3 minus negative 37 is the same as plus 37, so that would be 34 on top, and 4 minus 12 is negative 8 on bottom. I'm just going to leave that the way it is, because that is not going to make a integer. That's going to be a decimal. 34 divided by negative 8. Or up 34, left 8. 40 minus negative 24 over 21 minus negative 11. Once again, leave, change. Minus a negative is the same as plus. So that's 40 plus 24, which would be 64. And 21 plus 11 would be 32. Now that can be divided easily. That is 2. 64 divided by 32 is twice. So up to right 1 would be in simplest terms. Negative 40 minus negative 75 over negative 15 minus 55. So leave, change. Negative 40 plus 75 would be 35. And negative 15 minus 55 more would be negative 70. And both 35 and 70 can both be divided by 35, so I'm just going to simplify that a little bit, and that's really negative 1/2, or down 1, right 2. Down 1, right 2. All right, so as I mentioned before, we're going to get into exploring perimeter and area when it comes to shapes, and seeing how it's going to be either a linear or a quadratic pattern. So Misha wants to build a Wascal Rabbit pen. Wascal Rabbit. Old school comic. Wascal the Rabbit, and they want to build a pen that is 72 feet of roll of fencing to build the rectangular pen. So the first thing we're going to do is come up with what are some possibilities that we can make that fencing. So staying away from decimals, I'm just stick with whole numbers. I can make these two sides, because it does say it has to be a rectangular pen. Not sure if I mentioned that earlier. So that does mean the opposite sides do have to be the same. So if these two sides are 1, then that would take away 2 of the feet, meaning the other 2 sides would have to add up to 70. And that would mean that each side, as you can see in my figure, would have to be 35 on each side. Now, that's not the only possibility, because what if I make the 2 lengths 1 bigger? Let's say I make them both 2. So that would be 2 on each side would be 4, so that takes 4 of the 72 feet away. That leaves you with 68 feet left, which means the other 2 sides would have to be 34. Now you might be catching on to the pattern. For every 1 I take away from the width, it's making the length 1 bigger, or vice versa. So what I could do next is then do that exact same thing in a table on the back of this paper. So this was, if it was 1, it was 35, and then it's going to decrease by 1 for every 1 that you increase the length. Now, I know what you're thinking, well, that is going to make all the areas the same. Well, actually, it does not. As the lengths increase, the widths are decreasing. So it kind of reminds you of a inverse variation, which might have been something you did last year. But if we find the area, 1 times 35, all of these pens are going to have different size areas. Just because they have the same amount of fencing does not mean they have the same amount of area. Okay, so 2 times 34, which would be 68. And the next one, 3 times 32, is 96. Nope, I'm sorry, that was 33. So that's 99. 4 times 32. I just need enough where I can find the pattern is 128. And I'll do one more, which is 5 times 31, which would be 155. Okay, so now once I found that, the next thing I want to find is the differences of the area. So I'm now answering the questions on number 2 and 3. So find the difference in the area. So that's a difference of 33. And then the next one is a difference of 31, and then the next one is a difference of 29. So you can clearly see the pattern that's going on here. So the differences are decreasing by 2. So they have a common second difference of -2, and then the next one would be adding 27, and so forth. Okay. So now that we know that, we could easily write that as a recursive formula. So that would be any term is found by taking the previous term and adding -2x. So let's see, -2 times x, that's going to be a pretty big number here, would be -2 plus 37, it looks like. -2x plus 37 is what you would add to the previous term in order to get to the next term. So that's the recursive formula. And then the quadratic formula. So I'm going to now go to my graphing calculator. The x's, I'm going to use the length. X is 1, 2, 3, and had an area of 35 for the first term. Make sure I get this data in correctly. 68 for the second term and 99 for the third. So now I go to stat, calculate to number 5 for quadratic regression, and it's telling me that I've got -1x squared plus 36x. All right, so I'm going to now test that. So -1 squared would be 1 plus 36 times x is 36. That did not seem to work out. So let me try that again. Edit. 1, 2, 3, 35, 68, 99. Stat. Calculate. Quadratic regression. Alright, so there's that C term of 3.2 e -10. I assume that was the calculator calculating closest to 0. So I'm going to have to stick with my recursive formula for the time being and ignore the explicits. Sorry for that. Going to the homework. We've got a very similar question to the one we had just done a second ago. Fill in Adam's table with all the arrangements for the fence. So we've got 700 feet of fence, and we have a lengths and widths. As the lengths increase, so will the widths decrease, because it always has how many pieces? Let's see, 16 separate pieces. So if he has 1 as the length, that would be 7 as the width, and that is 16 pieces. But let's say he had 2 for the width, that would mean 4 total on the sides. If he had, it would leave him with 12 left over, so 6 on each of these sides. So this is going to be 5 and 4 and 3 and 2 and 1. So length. So the length in this case, length in feet, so each is 10 feet long. So 2 pieces would be 20 feet, 6 pieces would be 60 feet. This would be 30 feet and 50 feet. And you can clearly see all I'm doing is multiplying each by 10, because each fence piece is 10. 60, 20, 70, 10. And then the perimeter is always going to be the same, because you're using the same amount of fence pieces. So 16 pieces times 10 each is always going to be 160. That's already done for you in the table. And then the last thing you want to do is find the area. So length times width is how you find the area of a rectangle. So 20 times 60 is going to give you 1,200 feet squared. 30 times 50 is 1,500. 40 times 40 is going to give you 1,600. 30 times 50 is 1,500 again. And 60 times 20 is 1,200. And last but not least, 1 times 70 is 700. Now, something I haven't talked about in any of the other videos, whenever you have a quadratic pattern like this, you're going to notice in the table that it's going to have what we call a vertex in the middle. So the middle number here was 1600. So that's the number in the middle. And you think of kind of like the rainbow effect here. On both top and bottom of it, it's going to be the exact same. And then on top and bottom of that, it's going to be the same. And then on top and bottom of that, as you can clearly see, is the same. So it's kind of making that sideways rainbow shape that you can see. So that's the vertex. That's the highest point it's ever going to be. And we call that the maximum. Okay, so these are vocabulary terms you're going to see in other videos as well, but I did want to point that out, that you can see that what's happening is this number's in the middle, and everything above and below that is always going to be the same. That will always happen in quadratics. There's always going to be that middle term. Because if you think about a parabola, I know we've talked about that word as well, that's the shape that the graph makes. It has a highest point, but then if you go equal distance left and right, both of those 2 points are also going to have equal heights as well. All right, thanks again for watching. Please give it a like if it helped you learn something, and subscribe if you haven't done so already. Thanks again for watching. Have a great day.